Hello everyone, welcome back to my channel. So today we are going to do this question at Alien Dictionary, which is a hard problem on GFG. Though it is a hard problem, but it is a very easy problem. So let's quickly read the question. Given a sorted dictionary of an alien language having N words and K starting alphabets of standard dictionary. It is saying K standard alphabets. That means it will contain K nodes, right? We have to find the order of the characters in the alien language. So what is the question saying? That in this question it is saying that this question does not follow the normal dictionary order. That means what is a normal dictionary order? A, B, C, D, E, F, and so on. This is the way the normal dictionary is arranged. But it is not the case in this question. In this case, it's a different order. For example, if we have this question, we can consider. So, in this question, BAA comes before ABCD. But if we consider it according to our dictionary, ABCD would come before. But this is a different dictionary. This is alien dictionary. So, in this dictionary we have to tell the order. For example, if we have BAA, ABCD, ABCE, and what we can take DBCE. Cool. So if we take this question, then we have to compare and we have to tell them the order, that which element comes before what, and we have to return that order. That for example, B comes, if we compare these two, then it will say that B comes before A for sure. That is why this BAA comes before ABCD. Then if we compare this ABCD with ABCA, it will say okay, A is same, okay, let's move to next. Okay, B is same, move to next. C is same, move to next. Okay, D and E. Okay, so by this we will understand that okay, E always comes after D, and in this we saw that B, not B, A always came after B. A always came after B. C always came after D. And what if we compare these two? We will get okay, D comes after what? Yes, A. So, what we got in this question? What can you see? This is a graph. This is the adjacency list. It is saying that we have B, which is connected to A. Then we also have D, which goes to E. Then we also have A, which goes to D, right? But since here A, B, C, D, E would be the graph's nodes, so that means C was also there. That means C is a different node. So this is our directed graph. So can you tell me that what we have to do after this? Since we have to tell the order that B always comes before A, right? D always comes before E, A always comes before D. So we have to tell its order. So this kind of order, can you get an intuition that what we know? Can you tell me? Yes, we have to use topological sorting in this order. So what is topological sorting? In topological sorting, we have to do this. We will see the code after that. So we will be doing topological sorting, and we just have to return that string and that will be the answer. So let's look at the code quickly, right? Yes. Yes, and one more thing, I will be providing you with the topological sort code and the code of this alien dictionary in the description box. So do check it out if you need it. So yes, I have also commented the code so that you can read according to your reference. So what we are doing initially, we are creating the adjacency list. For example, in this question, we converted these strings BAA, ABCD, ABCE, DBCA, right? All these strings, we converted these to this. What is this? This is the graph. How we store a graph? Adjacency list. So we are converting these strings to the adjacency list, right? We are converting these strings to the adjacency list. Then what we will do? We will be performing the topological sort on this graph, and we will be simply returning the topological sort answer, and we will be storing it afterwards, and we will be returning it. So let's read. In this we have stored the adjacency list. How we are storing? We are uh, we are doing it from I equals to 0 to I equals to n minus 1. Can you tell me why we are doing it to n minus 1 instead of less than n? Can you tell me? Yes, because for example, if this is my zeroth index 1, 2, 3, then we will be comparing the 0 with 1, 1 with 2, right, and 2 with 3. But if I did it till 3, then who will be compared with 3? It has no one, right? So it will be giving me an error. That is why we cannot do it. There is no one with whom 3 can be compared. That is why we are doing it till 2, or we can say till n minus 1, less than n minus 1, right? Because this one is n minus 1 and this one is n minus 2, and since we are doing it less than n minus 1, that means it's equal to n minus 2, right? I hope you got it. Then we are storing the strings. That means, for example, in this question, if I had this, if this is dictionary of I, then this is dictionary of I plus 1. So therefore this is s1, this is s2. What is s1? Can you tell me what is s1? S1 is BAA. S2 is, let's see it once again, ABCD. So S2 is ABCD. So what we will be doing, we will be comparing them, right? We will be comparing, first we will be comparing this, then if these are equal, then we will be comparing this, then this, and since it has no one, and yes, one more thing, we will be taking the minimum of what? Minimum of the length of these two, because we will be running the loop till the minimum of the length of these two, right? For example, in this part we have the length 3 and 4. BAA's length, its length is 3, this length is 4. So we will be running the for loop till 3, right? So let's see what the code says. In the code, it is, yes, this is only what we are doing. We are taking the length as minimum of both the strings length. Then we will be comparing the strings. How are we comparing? We are running the for loop till for the complete length, that is we found the minimum of both. Then we will be saying that what if an element of a ith element of first string and ith element of second string is not equal. In this case, as in this case, it is the 0th element only. At I equals to 0 only I got this condition that the S1's 0th element and S2's 0th element are not equal. So what we will do? We are storing it, yes, we are storing s1's ith character from and s2's ith character as 2. Why? Because if we compare how were we storing in the graph, we were storing that okay, a always comes after b or b always comes before a, right? So I have taken this b as my from, and I've taken this A as my 2. That is, we are going from B to A. That is, we are going from S1's ith element to S2's ith element, right? So this is my from and this is my 2. So what we are doing, we are storing it in the adjacency list. How are we storing? We are storing, okay, in the from, in the adjacency list, push 2. And why are we doing this minus a? We are converting these a, b, c, d, all the nodes, all the character nodes to number. For example, this A will be converted to 0, B will be converted to 1, C will be converted to 2, etc. etc. Why does this happen? Because, for example, if I do A minus this, then it will be 0. If I do B minus this, then it will be 1. If I do C minus this, it will be 2, right? So we are converting these characters to numbers. And yes, and whenever I found the first distinct elements in the two strings, I have to simply break. What I have to do, I have to simply break, and this way I have created my complete adjacency list. That means till now I have converted these strings to my directed graph, and yes, I'm sorted. If I know topological sort now, I have to simply apply topological sort. Now let's look at the code of topological sort as well. So this is the code. We are getting the in degree vector. I hope you know what is in degree vector. In degree vector. What is the meaning of in degree? In degree means the number of edges incoming to that particular node. For example, if I have this one, this is connected to this two. I have one more 5 which is connected to this, and one more edge which goes from 3 till 1 from till 3. So can you tell me what is the in degree of 1? The number of edges coming to 1. Yes, it is this one and this one. So what is the in degree of 1? In degree of 1 will be 2. So similarly, yes, what is the in degree of 2? How many edges are coming to 2? No edges. So in degree of 2 will be 0. How many edges are coming to 3? 1. How many edges are coming to 5? 0. So these are the in degrees of all the nodes. And in my vector, I will be storing all the in degrees of these nodes. So I will be initializing the in degree vector as 0. That is the size of all the. This is basically an array. You can take a vector as well. So I am initializing all them as 0 because the size will be n. Size will be n is the number of nodes. For example, if we had this, it is this 1 2 3. If it is one based indexing, so 5 is there, so that means 4 is also there, but 4 is not connected to anyone if it is not given. So in this we are taking in degree array, and we are initializing it to 0. All the elements are 0. Now we will be getting how many nodes, like these values, that what is the in degree of which node, that we are getting here. We are traversing to all the nodes, then we are traversing through its neighbors, and then we are increasing the in degree of every neighbor by 1. For example, if we come at 1, right, so 1 will say that okay, my neighbor is 3. Why is the neighbor 3, not 5 or 2? Because the edge is going from 1 to 3, so they are the only neighbors, because the graph was directed. So one will say that okay, increase the in degree of my neighbor 3 by 1. So this way it will continue, and it will increase the in degree of all the neighbors of every node by 1. So we got the in degree vector till now. Now what we are doing, we are creating a Q data structure, and in Q data structure, for example in this question if we see, we will be creating a Q data structure, and in Q data structure what we will be inserting, the main thing, we will be inserting all the elements that we have as in degree 0. So can you tell me who all have in degree 0 in this? The elements are 2 and 5. 4 is also the element, right? So 2, 4, 5, they have in degree 0. So I will be initially putting them in the queue because they have initially in degree 0. So here we are declaring, then we are pushing all those elements which have in degree 0 in the queue. Done. Now what we are doing, we are simply traversing through the queue, that till the queue is not empty, continue this. So what does this say? We are storing the front queue element and popping it, simply as we do in the BFS. Now what we are doing, since we have, yes, one more thing, that in the topological sort vector, that is in this vector that we will be returning, we have to push only those elements which have in degree 0. So that is why we are pushing the node in the topological vector, in the topo vector, because node already has in degree 0, because node is in queue, and I inserted in queue only those elements which have in degree 0. So right, so now we have our node inserted in the topological, in the topo vector. So now we will be traversing through all the neighbors of that node, and I will be decreasing, that is minus 1 the degree of all its neighbors. And yes, just see it what I have written. We will be traversing through all the neighbors of that node, that is adjacency list. In that we will be traversing of that node. then we will be decreasing the in degree of that element by 1. Then if at any point I found that okay, your in degree becomes 0, immediately push it in the queue, because yes, I have to do that only. I have to push all the elements that have in degree in the queue 0. So I will be doing that. I will be returning the topo vector. This topo vector has my complete ordering of the numbers, right? So now let's see. We have called the function. We have put k because k was the size of the number of the nodes, and in the beginning we saw that k, because it contains k equals to 4, for example, so it means it contains a b c d, so it is the number of nodes. So we are storing it in another vector, but we have to return string, so we will be storing it in string. And how will we store? We will traverse to the complete vector and push in the string. What will we push? We will be converting the element of that topo vector. How will we convert? We will be adding plus a, because we subtracted a because before. That is why we will be adding. And yes, we are sorted. We got a string, that is, we converted this complete vector and we stored it in the string. Now we just have to return the answer string, and yes, we are sorted. Let's submit this code. Yes, complete, problem solved successfully. So this was the C++ code. This is a very easy solution, and I hope you liked my video. If you liked my video, please do like, share and subscribe, and do not forget to comment down, because that is only what keeps me motivated. Thank you.